The quadruple axel was once figure skating's last unlanded quadruple jump. For decades, athletes, coaches, and biomechanics researchers all looked at the sheer physics required for this jump and honestly wondered if it would forever remain out of human reach. I mean, it was the ultimate barrier. But today, in this explainer, we're going to look closely at the exact kinematic profile of how that impossible barrier was finally broken. And we'll be using some absolutely fascinating data to do it.
On September 14, 2022, Ilia Malinin became the first skater to land a ratified quadruple axel in competition. That historic September day effectively ended the unlanded quadruple era. But there's a second crucial moment to keep in mind, and that's March 2023. While the first landing proved it was possible, it was the 2023 World Championships where advanced tracking technology finally allowed scientists to capture the granular, high-definition data of this incredible feat.
But what do measured data reveal about his successful approach? Okay, let's dive into this. To truly appreciate the numbers we're about to explore, we really have to look past the awe of the jump itself and break down the specific mechanical riddles that Malinin had to solve. The quadruple axel carries a massive base value of 12.50 points, the highest of any jump, and for very good reason. It demands something literally no other jump does.
The axel begins with a forward takeoff and ends with a backward landing, so the quadruple axel is classified as 4.5 rotations. That extra half rotation is the whole shebang. Every other quad requires 4 rotations, taking off backward and landing backward. Because the axle forces you to leap forward from an outside edge without the vaulting assistance of a toe pick, you have to find the time and space in the air to complete 4.5 turns. It requires a truly extreme flight phase.
Now, let's look at the mechanics of getting into the air. Rotation begins during the takeoff process, while the blade is still interacting with the ice. The full rotational action does not occur entirely in free flight, and this brilliantly illustrates an important reality of skating biomechanics: the skid. Every axle involves some degree of skidding on the ice before liftoff, which means skaters don't actually complete a full 4.5 rotations purely in the air. Traditional theory suggested that a heavy skid acts as a brake, converting horizontal momentum into vertical lift. Keep that traditional theory in mind, because what we're about to see is mind-bending.
Let's build our understanding with some hard numbers. Biomechanical tracking of Malinin's successful quadruple axel at the 2023 World Championships reported a measured maximum vertical height of 0.84 meters, referenced specifically from the toe pick. Guys, 0.84 meters is massive. It gives the skater the essential flight time required to spin 4.5 times, but height is only one piece of the puzzle.
In addition to that incredible height, the data revealed a takeoff speed of 7.29 meters per second at a horizontal distance of 2.96 meters. This is where things get wild. As I mentioned earlier, traditional biomechanics tells us that to jump higher, a skater must use a longer, wider skid to brake, sacrificing their forward speed and jumping distance. But these measurements show Malinin maintained a blazing fast takeoff speed and covered nearly 3 meters of horizontal distance while simultaneously launching almost a meter into the air.
To really grasp how unique this is, we need a baseline. At the same event, his triple axel measured 0.71 meters in height, 6.23 meters per second in takeoff speed, and 2.37 meters in distance. What's truly fascinating here is a direct comparison. We are looking at the exact same skater on the exact same ice at the exact same competition. When he added the extra rotation for the quad, traditional theory dictates his speed and distance should have dropped to accommodate the need for more vertical height.
But they didn't drop. His quadruple axel was therefore higher, faster at takeoff, and longer. He achieved a simultaneous increase across the board. This indicates a momentum maintenance strategy fueled by superior physical power. He essentially bypassed the traditional braking effect, generating immense power to launch upward without sacrificing his approach velocity.
And just how much of an outlier is that height? The 0.84 meter height was also approximately 35% above the 0.62 meter mean measured across 24 world-class triple axels. The statistics researchers ran on this probability distribution put the upper tail probability of hitting that height compared to the world-class triple axel distribution at roughly 4.66 times 10 to the negative 13th percent. It is a complete statistical anomaly. We are literally looking at an outlier in human performance.
Now, we have to be careful with how we interpret this data. These observations do not show that the jump was physically impossible, overturned biomechanics, or eliminated a universal height-speed trade-off. It's really vital to remember that these metrics are observed individual measurements. The universal laws of physics absolutely still apply, and the height-speed trade-off is still a reality for the vast majority of jumping mechanics.
They also do not establish one technique that every skater can reproduce. Instead, the measurements describe one extraordinary performance. What works for Ilia Malinin might not work for another elite athlete. For instance, other skaters have attempted the quad axel by deliberately slowing down, trying to trade all their horizontal speed purely for vertical height. But this data specifically highlights Malinin's unique, perhaps physiologically unparalleled execution on that day. In this successful attempt, Malinin combined exceptional vertical height with unusually high takeoff speed. To get 4.5 rotations, you must go incredibly high, but to land cleanly, you must maintain intense forward momentum. It's like threading a microscopic needle, but Malinin managed to synchronize both extremes perfectly.
The achievement did not break physics. It revealed Malinin's distinctive kinematic strategy within physics and transformed the quadruple axel into a landed, competitive reality. By rethinking how horizontal momentum can be maintained rather than braked into vertical lift, he gave us a brand new blueprint for what the human body can achieve on ice. So knowing what we know now about the incredible kinematic demands of the 4.5 rotation axle, it begs the ultimate question. With athletes now actively optimizing for extreme height and momentum maintenance, how long until we see data tracking a quintuple jump? Something to think about until our next explainer.